presenters, ladies and gentlemen. We are delighted to welcome all of you to the Postgraduate Institute of Science, University of Peradeniya for the inauguration ceremony of Rescon 2025, the 12th Annual Research Congress. We will begin our ceremony with the academic and ceremonial procession, a traditional mark of honor symbolizing the academic heritage and excellence of our university. The procession is now entering the PGI's premises, as you may see on the screen shortly. This procession is led by traditional Canadian dancers, followed by our distinguished dignitaries of the day. The Vice Chancellor of the University of Peradeniya, Professor Terence Madhujit, the Chief Guest, Professor Janaratna, Senior Principal Investigator at A-STAR, IMCB, National University of Singapore, the Dean of the Faculty of Science, Professor Sanath Rajapaksa, the Director of the Postgraduate Institute of Science, Professor Nanda Balasurya, our keynote speakers, Professor Claudia Verani from the University of Windsor, Canada, and Professor Veranja Kannaratna, Vice Chancellor of ESOP University, the Chair of Rescon 2025, Professor Manavadevi Ganehenake, Dr. Gajapa Allepola, Secretary of the Rescon 2025, Professor Namal Priyantha, Editor-in-Chief, Rescon 2025, Deans of the other faculties, Directors of the Postgraduate Institute, University of Peradeniya, Librarian, Registrar, the Bursar of the University of Peradeniya, Chairpersons of the Board of Studies in PGIS, and other members of the administrative staff of PGIS. Ladies and gentlemen, the procession is approaching the PGI's auditorium. May I kindly request all of you to rise as we prepare to welcome the dignitaries to the hall. Please remain standing until the dignitaries have taken their seats. Thank you. Thank you, ladies and gentlemen. Please be seated. We now hand over the proceedings to the Secretary of the Organizing Committee, Dr. Agajaba Alafala, for the inauguration of Rescon 2025. Thank you.
Good morning, everyone. The Postgraduate Institute of Science of the University of Peradeniya proudly presents Rescon 2025, the 12th Research Congress, continuing its tradition as one of Sri Lanka's premier scientific research forums. This year's Congress brings together postgraduate scholars, academics, and researchers from across Sri Lanka and overseas, all united by their passion for discovery, collaboration, and innovation. We are honored to welcome our distinguished dignitaries this morning, the Vice Chancellor, Professor Terence Madhujith, the Chief Guest, Professor Jayantha Gunaratne, Senior Principal Investigator, A-Star IMCB National University of Singapore, the Director of the Postgraduate Institute of Science, Professor Nanda Balasurya, the Dean of the Faculty of Science of University of Peradeniya, Professor Sanath Rajapaksa, keynote speaker, Professor Claudio Verani, the Dean, Faculty of Science and Professor of Chemistry, University of Windsor, Canada, keynote speaker, Professor Veranja Karunaratne, Vice Chancellor, ESOFT University of Sri Lanka, the Chairperson of Rescon 2025, Professor Manava Devi Ganahenage, distinguished guests, members of the academic and research community, staff, students, and presenters. On behalf of the organizing committee, I warmly welcome all of you to the inauguration ceremony of Rescon 2025. To officially commence the ceremony, let us all rise for the national anthem of Sri Lanka.
Namo
Thank you. Thank you. Please be seated. Light symbolizes the knowledge and wisdom that dispels darkness. Following this long-held tradition, we now move to the ceremonial lighting of the traditional oil lamp. It is my honor to invite the following dignitaries to light the lamp. Professor Terence Madhujit, the Vice Chancellor of University of Peradeniya, Professor Jayantha Gunaratne, the Chief Guest, Professor Nanda Balasurya, the Director of the PGIS, Professor Sanath Rajapaksa, Dean, Faculty of Science, Professor Claudio Verani, the keynote speaker, Professor Viranja Karunaratne, the keynote speaker, Professor Manavadevi Ganahenage, Chairperson, Rescon 2025, Professor Shyam Bannayaka, Dean, Faculty of Allied Health Science, representing all Deans of University of Peradeniya, Professor D.K.N.G. Pushpakumara, Director, PGIA, representing all postgraduate institutes, Professor Sumudu Rubasinghe, Chairperson of the Board of Study in Plant Sciences, representing all boards of studies, Mr. K.A.B. Damunupala, Acting Registrar, University of Peradeniya, Ms. A.A.S. Priyadarshini, Deputy Registrar, PGIS, and Ms. Ishra Iqbal, President of the YRF, representing all students. Thank you very much. Please be seated. The Postgraduate Institute of Science continue to serve as a national hub for postgraduate education and research excellence. Please enjoy this short video presentation showcasing the vision and achievement of PGIS.
Science begins with our unquenching curiosity to understand the grandeur of nature and the universe. The Postgraduate Institute of Science, PGIS, was established in the year 1996 to ensure the transfer of modern scientific knowledge to the next generation.
The PGIS offers master's degrees covering a majority of fields of the sciences, and it mentors MPhil and PhD students to provide their expertise towards national and international development, serving at research institutes around the country and the world. The institute has produced over 6,000 professionals with postgraduate qualifications through its postdoctoral, PhD, MPhil, MSc and postgraduate diploma programs.
The academic programs of the PGIS are conducted through 11 boards of study, namely Biochemistry and Molecular Biology, Biomedical Sciences, Chemical Sciences, Earth Sciences, Environmental Science, Mathematics, Physics, Plant Sciences, Science Education, Statistics and Computer Science, and Zoological Sciences. The programs of these boards are conducted in close collaboration with the Faculty of Science, University of Peradeniya.
The PGIS was established with a vision of becoming an internationally renowned center of excellence for postgraduate training, innovative research and development in science.
To strengthen teamwork, collaboration and harmony among the young researchers at the PGIS, the Young Researchers Forum, the YRF, has been established. It encourages students to engage in activities, both co-curricular and extracurricular. The YRF publishes the Scicitator, a magazine highlighting their ongoing research and scientific reviews.
The PGIS organizes the annual Research Congress, Rescon, to provide a platform for students and scientists from institutions spanning the country and the world to share their groundbreaking research findings.
Rescon was first conducted in 2014, and this year marks the 12th consecutive conference which is organized by the Board of Study in Chemical Sciences. In preparation of the main event, we have already conducted 5 pre-conferences.
In 2025, the Congress is featuring presentations under 6 key themes: AI in natural sciences or industrial aspects, Earth and environmental sciences, ICT, mathematics and statistics, life sciences, physical sciences and science education.
Out of more than 270 abstracts received for Rescon 2025, 236 abstracts were selected through a double-blind process of 2 independent experts. They are all Google indexed and included in the proceedings with unique ID number.
The Congress is the collective effort of so many.
We have around 80 members in the organizing committee working under 8 subcommittees and the Young Researchers Forum. Rescon 2025 is the outcome of the unwavering effort of our team.
Rescon 2025 is the largest and the most glamorous of its kind in Sri Lanka and guarantees 2 days filled with the true beauty of science. We proudly invite you to Rescon 2025.
Thank you. May I now invite our distinguished dignitaries to the head table. Professor Terence Madhujit, the Vice Chancellor of University of Peradeniya, Professor Jayantha Gunaratne, the Chief Guest, Professor Nanda Balasurya, the Director of the Postgraduate Institute of Science, Professor Sanath Rajapaksa, Dean Faculty of Science, Professor Claudio Verani, Keynote Speaker, Professor Veranja Karunaratna, the Keynote Speaker, Professor Manavadevi Ganahenage, the Chairperson of Rescon 2025. Please proceed to the head table. Thank you very much. Now I cordially invite Professor Nanda Balasurya, the Director of the Postgraduate Institute of Science, to deliver the welcome address.
Professor Terence Madhujit, Vice Chancellor, University of Peradeniya, Professor Jayant Gunaratna, Chief Guest, Professor Claudio Verani and Professor Veranja Karunaratna, Keynote Speakers, Professor Sanath Rajapaksa, Dean, Faculty of Science, Dean of the Faculties, Directors of the PG Institute, members of the Board of Management, PGIS, Head of the Department, Faculty of Science, former Directors of the PGIS, distinguished members of the academic staff, invited guests, postgraduate researchers, ladies and gentlemen, good morning all. It is a great privilege to warmly welcome you to Rescon 2025, the 12th annual Postgraduate Research Congress of the PGIS, Postgraduate Institute of Science, held today and tomorrow at the PGIS, guided by the theme, Synergy in Science, Unity in Discipline for a Better Tomorrow. This Congress places emphasis on collective scholarship, strategic partnership, and integrated scientific achievement. Ladies and gentlemen, we are deeply grateful to our Vice Chancellor, Professor Terence Madhujit, for gracing this occasion, for his unwavering support and leadership towards enhancing the postgraduate research and academic excellence at the University of Peradeniya. Your presence today is greatly appreciated. Established in 1996 and affiliated with the University of Peradeniya, the PGIS continues to work the dedication and provide high quality postgraduate education, encourage new ideas and research, and support the important needs of our country through its academic and research activities. Distinguished guest, Rescon was inaugurated in 2014 with the primary aim for enhancing postgraduate research culture in Sri Lanka. Out of the past decade, it has evolved into a leading national forum, providing opportunities for researchers to disseminate findings, exchange ideas, and build a strategic collaboration that address important scientific issues. In the lead up to this event, a series of pre-conference workshops were successfully conducted, covering timely and emerging fields such as neuroplasticity and brain health, academic challenges, bioanalytical application, clean energy solution, and technology-driven crop breeding. These experiences expand their outlook and improve our participants' professional capacity. This year's Congress proudly showcased 215 oral presentation and 21 poster presentation across disciplines including life sciences, physical sciences, earth science and environment sciences, computing, mathematics and statistics, science education, and AI and industry applications. The addition of keynote and plenary sessions delivered by eminent scholars promises to enrich our collective academic experience. ladies and gentlemen, we are honored to welcome Professor Jayantha Gunaratne as our chief guest, Professor Claudio Verani and Professor Veranja Karunaratne, our keynote speakers. Their presence had immense value and also prestige to Rescon 2025. Esteemed colleagues, I wish to express my sincere appreciation to Professor Manadevi Ganahenage, Congress Chair, Dr. Gajaba Lepola, Secretary of the Congress, Professor Namal Priyantha, Editor-in-Chief, the editorial committee, reviewers, and the members of the Board of Studying Chemical Sciences for their exceptional dedication in organizing this event. I also gratefully acknowledge the contribution of the Rescon organizing team, including the YRF members, and also members of the Kalakave Faculty of Science, and also PGI staff for their commitment and tireless support. Your contributions are truly commendable. As we aware and come at this Congress, let us strengthen our resolve to create new knowledge, foster innovation, build meaningful collaboration that contribute to sustainable national development and global scientific progress. Thank you. I wish you all productive, inspiring, and memorable Congress. Thank you.
Thank you, sir. It is my pleasure to invite Professor Sanath Rajapaksa, Dean, Faculty of Science, University of Peradeniya, to address the gathering. Good morning to everyone. Professor Terence Madhujit, the Vice Chancellor of the University of Peradeniya, Professor Jayantha Gunaratne, our chief guest today, Professor Nanda Balasuriya, Professor Claudio Verani and Professor Veranja Karunaratne, the keynote speakers of the Rescon, directors of PG institutes, deans of faculties, former directors of PGIS, Professor Manadevi Ganahenage, the chairperson of Rescon 2025, and Dr. Gajaba Lepola, the secretary of the Rescon 2025, chairpersons of boards of studies of PGIS, emeritus professors, heads of departments of the Faculty of Science, all academic staff members, administrative staff, non-academic staff members, presenters of Rescon 2025, distinguished invitees, ladies and gentlemen. First of all, I am extremely thankful to the organizing committee for the invitation extended to me to participate in this inauguration ceremony of Rescon 2025. In addition to my role as the Dean of the Faculty of Science, I am extremely happy to participate in this inauguration ceremony as a member of the Board of Management of the PGIS as well. I am personally delighted to witness this academic symposium happening for the 12th time, which has now become a major annual event of the Institute. On behalf of the Faculty of Science, I extend my heartiest congratulations to Rescon, which is a platform for postgraduate students of the PGIS and other researchers from all over Sri Lanka and other countries to present and discuss research. When it comes to the research work to be presented in the coming 2 days, it's noteworthy to mention that a considerably high number of research are interdisciplinary and many are conducted at inter-institute level as well. The Congress provides an exciting opportunity to share and disseminate knowledge of cutting-edge research and a platform to build networks among scientists across Sri Lanka and overseas. So as the Dean of the Faculty of Science, I feel proud to witness the excellent commitment of our faculty members, including the chairperson and the secretary of the main organizing committee and the chairpersons of all subcommittees towards the success of this conference. The biggest strength of the Faculty of Science is its research culture. And as far as I remember, our faculty members have published considerably high number of research articles in refereed journals in the previous years, despite all the obstacles we had to undergo during the past few years as a country. I am proud to mention that among the academic staff members of the faculty who are currently serving in the 8 departments, there are 40 with H-index 10 or above, and 17 are tier 4 level researchers. When we count the number of retired members, when we add them also the list goes beyond 35. So I believe our close links and close ties with the PGIS has led to this success. All our postgraduate researchers are registered at the PGIS for their MPhils and PhDs. I am sure that a substantial number of papers to be presented during the next 2 days will end up as full research articles in refereed journals within the next year or year after next. I can remember during the past few years, some abstracts published at previous congresses led to the publications ending in high impact journals. So without taking much of your time, I would like to wind up my short speech. On behalf of the Faculty of Science, I wish the presenters, organizers, and the participants a very fruitful symposium. Thank you very much. Thank you, sir, for those insightful words and continued encouragement towards research excellence. Rescon 2025 continues the tradition of making scientific knowledge freely accessible through the University of Peradeniya Digital Repository. It is with great pleasure that I now invite Professor Namal Priyantha, the Editor-in-Chief, to launch the Congress proceedings of Rescon 2025.
Good morning, everyone. So we just launched the proceedings of Rescon 2025, and this year we received more than 270 abstracts across the themes given here, and they were all subjected to double band review by 2 independent subject experts, and based on their evaluations, we had to reject little more than 10% of abstracts. And finally, we are set at 236, out of which 215 oral presentations and 21 post presentations, which will be presented within today and tomorrow. So this time, we gave specific identifiers, unique ID numbers for each of the abstracts, depending on the themes, as you can see here. Rescon 2025, AI-NI1, the first abstract in the theme AI in natural sciences and industrial aspects. And likewise, other themes are also given identity numbers. In addition, all the abstracts are Google indexed, and also the abstracts are given URIs, the uniform resource identifiers, which will be available from tomorrow onward for anyone to access abstracts through Google. Thank you.
Thank you, sir. Highlighting the most notable research from PGIS, the Research Highlights 2025 illustrates the breadth of scientific endeavor at our institute. I now invite Dr. Tiloka Aryasena, the Editor-in-Chief of the Research Highlights Committee, to launch the PGIS Research Highlights 2025.
Good morning, everybody. Today we are happy to launch the volume 10 of Postgraduate Research Highlights. This booklet is a compilation of research articles based on the research work of our MSc, MPhil and PhD graduates. There are 34 articles from various disciplines of sciences, and I would like to thank all the graduates, their research advisors, and the editorial committee of postgraduate research highlights for their contribution. I wish that this postgraduate research highlights 2025 would be an inspiration for our young researchers. Thank you.
Thank you, Madam. Please welcome Professor Terence Madhujit, the Vice Chancellor of the University of Peradeniya, to address the gathering.
Good morning, ladies and gentlemen. The chief guest today, Professor Jayanta Gunaratna from A-Star, Director PGIA, Professor Nanda Vipula Balasurya. The keynote speakers, Professor Claudia Perani from University of Windsor, Canada, and also long-rooted in University of Wayne, the United States. Professor Viranja Karunaratna, the Vice Chancellor, ESOFT Uni. Dean Faculty of Science, Professor Sanath Rajapaksha, Dean Faculty of Allied Health Sciences, Dean Faculty of Dental Sciences as well, Professor Shyam Vanhaka, all other deans. Rescon Chairperson, Professor Manavadevi Ganehenage, Rescon Secretary, Dr. Gajaba Lepola, Heads of Departments, Director PGIA, Acting Director PGIHS, Dr. Tushari Vidanage, Registrar, Senior Assistant Registrar of the PGIS, Bursa, PGIS, all academic heads of departments, academic staff members, emeritus professors, retired academics, non-academic staff members, PGIS students, paper presenters, other invited guests, ladies and gentlemen. It's a long list though. First of all, let me congratulate the PGIS, the director, and the entire team, Board of Study Chairperson, secretaries, all of you for organizing this for the 12th consecutive year in 2025, Rescon 2025. Now, University of Peradeniya being the center hub of higher education in the country, the longest, have the longest existence in this country. We are celebrating 83rd anniversary this year. The University of Peradeniya has nurtured many professionals, not only to the country but to the entire world. One of the best examples is Professor Jayanta here, who is sitting at the head table. Ladies and gentlemen, PGIA has been the oldest postgraduate institution of this country, followed by PGIS, which was established in 1996 here at Peradeniya, has progressed a lot over the last few decades. Comprising of 11 boards of studies, you have selected the right tagline or the theme for today's and tomorrow's two-day conference, Synergy of Science, which is extremely important. We are working as isolated entities, but we are not integrating these together. Now, why research? Well, at the turn of the century, in 1900, our life expectancy was just less than 40 years, ladies and gentlemen, which has shot up to almost 80 years at birth as of today in Sri Lanka. That's because of the inventions, advances in medical technologies, prevention of communicable diseases, vaccination, etc. And the quality of life has improved significantly. That is why We have these multimedia projectors, light. Just to name few, in 1775, steam engine have transformed the world. Then the invention of the phone, transistors, semiconductor transistors, internet in 1969, the personal computer along with microprocessor, discovery of penicillin in 1928. AI, although it has been a buzzword today, it has been tried decades ago. I happened to be at Illinois Institute of Technology, Chicago, a few months ago, where the cell phone, cellular phone was invented. The inventor had been there. They have started this work in 1943 and it became a commercial product in 1970s, which came to Sri Lanka in 1990s. So it's like everything has a long history. So we are enjoying this luxury thanks to the discoveries and inventions happened long ago. So although science came to sort of a plateau in 1960s, still we have to go beyond. The science has done some damage also to the world. Like one good example is environmental pollution. So who is going to find solutions? Again, all these scientists should find solutions. That is why we need this integrated approach, and that is why I said you have selected the best theme for this year. Now, we have set sustainable development goals, 17 of them. We have to meet them by 2030. It's just little above 4 years, not even 5 years. Are we ready, ladies and gentlemen? Well, some countries are far ahead. We had some deliberations in Beijing just a couple of weeks ago. I was also able to take part in. And China is way ahead of meeting sustainable development goals, way before 2030. We are to reduce emissions by 14.5% by 2030. We have to go towards net zero by 2050. Are we ready? Environmental pollution, air pollution. In 2023, you witnessed in Sri Lanka, it's not because what we generated, but some others generated were drifted to Sri Lanka, so particulate matter content shot up. So that is why the integration is important, not only just within the country, but across the globe, global south especially. We thought by 2019, we have eradicated most of these, at least controlled communicable diseases. But in 2019, we realized that it was not the case. The same thing happened nearly a century ago, repeated, COVID pandemic. So the world, we learned a lot of lessons. Again, within less than 3 years, the world was able to control the pandemic, again, thanks to this cooperation, integration, NCBI database, I can set you as a best example. Thanks to that, for changing viruses, we were able to change the vaccine production. Vaccine production happened in such a short span of time thanks to this sharing data, open science. So that is the beauty of integration and working together as a global community. And we are not just isolated country, although we are separated from the rest of the world by ocean, but we are connected. See, COVID came to Sri Lanka in less than 3 months. African swine flu, which devastated swine industry in Sri Lanka. Still, we cannot enjoy pork simply because of African swine flu. So emerging and re-emerging diseases, we have to take care of, ladies and gentlemen. Chemistry can do wonders. One good example will be our chief guest and also keynote speaker, Professor Claudia himself is a chemist. So we have to find solutions. Now that scientists should be at the helm of in policy making, should be heading critical organizations, which has happened over the last year with the changes that happened in the country. I'm really happy. Most of the institutions are headed by qualified people who have a very good background knowledge in science. That is the mere reason why we released 2 of our academics from Faculty of Science to head 2 institutions, critical institutions, Central Environmental Authority and Renewable Energy Authority, as I remember. Yes, 2 of them are proud academics of this institution. They have been released full time to work on this. So that is exactly what should happen. Now I heard that we were talking just a while ago when we are coming in the procession in Mena, we were to set up some wind turbines, one of the best solutions for the country. And if you are dropping that, assuming that birds will be damaged, is one of the worst decisions that I can think of, at least. I am not an expert in that area. Ladies and gentlemen, there are 3 things that we have to worry about, mainly globally. One is energy crisis. At least we have some solutions. According to previous projections, by 2050 we will be running out of fossil fuel, but it is not the case anymore. In at least North America, in Europe, most of the public transport buses are either hydrogen or hybrid at least. What is the situation in Sri Lanka? So we have to seriously think about solar panels, rooftop solar panels. Again, there are certain issues. Now in Kandy, whether it is a suitable solution. Can't we have solar gardens elsewhere? So always this is a compromise. In 1920, the forest percentage in Sri Lanka was nearly 50%, which has come down to 30%. Of course, there's a compromise. So ladies and gentlemen, that is why all these natural sciences, hard sciences, social sciences should be well integrated to find solutions for the problems that we are facing in the world. So without much ado, let me once again congratulate all the presenters, junior authors, senior authors, and make sure that these abstracts are not just shelved and collecting dust these days on the World Wide Web. That is true, but still you should progress with them. You should come up with an tangible output should be there. Otherwise, just for the sake of doing research is not worth. As University of Peradeniya, we are fully committed. In year 2024, we produced more than 700 full journal articles. And science, Faculty of Science, the second highest in terms of numbers. And during the hardest hit time of our era, in the year 2022 as well as in 2023, the university spent 100 million of rupees for research. And this year even more. We reserved 150 million for research, for multidisciplinary research at University Research Council as well as University Research Grants. And a few years ago, I happened to be the founding director of University Research Council. So we started, Professor Parakrama Karunaratna was the Deputy Vice Chancellor those days. He helped me a lot in establishing researcher award scheme, Tier 4 star, and providing article processing charge up to $1,000 per paper for maximum of 2 authors. And this year, I'm happy to say, we took another step ahead by offering 25,000 rupees for anyone who from University of Peradeniya, of course, permanent staff members, 25,000 rupees for Q1 journal article. So this is a commitment although we are restricted by budgetary restrictions, we have not limited the spending on research. So that is our commitment. I am happy. There are world 2% academics, 6 of them are here from University of Peradeniya. And in terms of university ranking, we are at the very top in the country, most either first or second in almost in all ranking bodies, organizations, as well as Professor Claudia Verani. We are standing at the 1,648th position across more than 50,000 universities in the world. Now, for a small country with a per capita GDP of just 4,000 US dollars, reaching that level is not easy. So, ladies and gentlemen, that is one more thing that I should talk on, spending one more time of your valuable time, 1 minute. Our per capita GDP is just barely touching 4,000 US dollars. Our poverty in 2023 was 27%, which has come down to 24%, expected to come down to 22%. So we have to take care of all these. We have to feed the nation. We have to increase food supply by 25% by 2030. Otherwise, we won't be able to feed the nation. So it's all compromise. Protecting environment is one of our priorities. At the same time, we have to feed the nation. We have to keep the system running. So there, the science can do wonders. Science can contribute a lot to improve this, not only this country, but the rest of the world. We are not just one country. We are part of the global community. So let me congratulate all the researchers who are presenting today and tomorrow. I wish you all the very best. Thank you very much for unwavering support in organizing this grand event, flagship event of this year. Thank you.
Thank you, sir, for those words of encouragement and vision. Next, to introduce our chief guest, I now invite Professor Malkanthi Daundasekara, Professor of Botany, Faculty of Science, University of Peradeniya.
Good morning, ladies and gentlemen. It's my great pleasure to introduce our chief guest, Professor Jayantha Gunaratne, a world-renowned leader in biomedical research with nearly 3 decades of pioneering work in therapeutic discovery, precision diagnostics, and the training of future scientific leaders. Professor Jayantha Gunaratne earned his Doctor of Science from Tokyo Institute of Technology, following a BSc Special in Chemistry from the University of Peradeniya, and completed advanced postdoctoral training at the Scripps Research Institute, University of California, San Diego. He currently serves as Senior Principal Investigator and Deputy Division Director at the Cell and Molecular Therapy Division at the Institute of Molecular and Cell Biology, A*STAR, Singapore, where he leads a multidisciplinary research program delivering breakthrough innovations in translational medicine. His impact is reflected in over 100 publications, multiple patents, and a remarkable record of industry collaborations advancing precision medicine globally. Beyond research, Professor Gunaratne is deeply committed to education and mentorship. He is an adjunct professor at the School of Medicine, National University of Singapore, a founding adjunct faculty member of the Imperial College London Nanyang Technological University Joint Medical School, and has also served on the faculty of the University of Runa Medical Faculty. Professor Gunaratne's career stands as a testament to the power of science to transform lives through discovery, innovation, and the nurturing of the next generation. ladies and gentlemen, please join me in extending a warm welcome to Professor Jayantha Gunaratne.
Good morning. Thank you, Malkanti, for giving a kind introduction to me. Good morning, distinguished guests, organizers, fellow scientists, and dear students. I think that I have to start my presentation, or not presentation, it's a talk, just expressing my sincere gratitude to the, especially Professor Mana Devi Kanahanige, the chairman of Rescon 2025, and PGIS director, Professor Nanda Balasurya, and the organizing committee for inviting me to serve as a chief guest of this prestigious scientific gathering in Sri Lanka. So also I have to thank Professor Champika Hettiarachchi sitting there, who invited me to deliver a lecture at their Inspire lecture series during COVID time, as I remember. I think that was the main reason I am sitting here as a chief guest. So thank you, Champika. And it is truly an honor and really a privilege to be here as a part of this remarkable event. It is a bit heavy for me, actually, as a chief guest here, because my seniors, couple of seniors, my teachers sitting in the audience, Professor Anura, I see, Professor Chandani, I see, so who guided me to go this far? There are several other people, my colleagues like Malkanti. So thank you all. And standing here, I feel immense pride and joy to see the same ground that once shaped my first steps as a scientist. So this home gave me, as well as many others, our first experience of scientific discovery. From here, generation of scholars have gone on to contribute countless ways to improving the quality of human life across the world. I am happy that PGIS has evolved into a beacon of advanced research and higher learning, connecting Sri Lanka to the global scientific frontier. Congratulations. In fact, it was not there at my time. Once Professor Namal Priyantha invited me to visit here, and I saw they were struggling to build this institute to this level. Again, congratulations. Let me share one reflection from my own journey. If you wish to become a researcher or scientist, do not choose as a job or even as a career. Science is, it's actually passion as a way of life. So science is not a transaction. So it is generosity, the willingness to work hard for the world, often without expecting immediate rewards. It is a lifetime commitment to advancing science in service of society. In that spirit, I often speak of kind of modified ikigai. I'm not sure whether you have heard about this one, probably. I was in Japan for 5 years. A Japanese concept that translates a reason for being. So there are 4 primary elements there. Number 1, what the world needs, the mission, is a number one for me. Number two, what you are good at, your vocation, number two. If you are not good at, you can't do. Third, what you love. That is the passion. And the last one, what you can pay for, your profession. I follow this order. It's not balancing as Ikigai taught. And please follow this one if you really want to be a true scientist. You will be successful. Last week, I attended a conference in Greece. It's a Hania, very beautiful island. A land is still guided by the wisdom of great philosophers such as Socrates. Even after 2,500 years, they continued Socrates' tradition of not just monologue, the dialogue, multilogues. And it is questioning, reasoning, and especially learning together as Vice Chancellor mentioned just earlier. It is integration, work together. This is truly important. Connecting minds within one of the best universities in the world here. So you have a very good environment to do so. Basically, I hope Rescon 2025 will be such a meeting, one that fosters deep scientific dialogue and multilogues, not just presentation only. Please talk, discuss. This is very important. A place for relaxation and reflection and the joy of connecting minds. This is truly important. It's a Socratic method. And Sri Lanka has always been a nation of intellect and creativity. I see out the people who are living in outside. Super good. So I'm really proud. And under a strong scientific ecosystem that should be created by the government, hopefully they are in that line. And this country can rise from the developing world to the frontier of global innovation. Not by trading or tourism, but by investing in advanced science. Science that uplifts lives, drives technology, and brings Sri Lankan-born Nobel-winning discoveries from this soil. To all young scientists here, believe it is possible. That is possible. Curiosity, collaboration, and most importantly, courage can transform our island into a center of excellence. Not only for Sri Lankan, but for humanity. I wish the organizers and all participants every success in making Rescon 2025 resounding success, a celebration of intellect, inspirations, and innovation. The last point, small minds discuss people. Average mind discuss events. Great mind discuss ideas. Great minds, this hall is full of great minds. So, this great mind gather here at Rescon 2025 to spark ideas that shape the future. Thank you very much.
Thank you, sir, for that inspiring and insightful address. And may I kindly request you, sir, to come to the front to receive the token of appreciation. May I invite Professor Terence Madhujit, the Vice Chancellor of University of Peradeniya, to present the token of appreciation to the chief guest. Thank you very much. We would now like to invite the distinguished members of the head table to take their seats in the front row as we proceed to the keynote sessions. Thank you. To introduce our first keynote speaker, may I invite Professor Manavadevi Ganehenage, the chairperson of Rescon 2025, to introduce Professor Claudio Verani, Dean and Professor of Chemistry, University of Windsor, Canada.
Good morning, ladies and gentlemen. It is my great pleasure to introduce our keynote speaker, Professor Claudio Verani, Dean of the Faculty of Science at the University of Windsor, Canada. Professor Verani is a distinguished scholar and a visionary leader whose career reflects a deep commitment to re-imagining science education for a rapidly changing world. Before joining the University of Windsor, Professor Verani spent over 2 decades at Wayne State University in the United States, where his pioneering research in physical inorganic chemistry, spanning molecular electronics, renewable energy, environmental science, and drug development earned international recognition and support from leading research agencies. I first met Professor Verani during ISAC 2017 conference at the University of Manchester in the UK while he was still at Wayne State. That accidental meeting led to a delightful discovery that my former undergraduate student, Danushka Ekanayaka, now Dr. Danushka Ekanayaka, was pursuing his PhD under Professor Verani's supervision. The friendship that began at that conference has grown over the years, and it has now brought him to Sri Lanka as a keynote speaker at Rescon 2025, a connection I deeply value and cherish. As Dean, Professor Verani continues to champion education that blends critical thinking, creativity, and hands-on problem solving, preparing students to thrive in the workforce of the future. Beyond his academic excellence, Professor Verani is also an artist and a musician who believes creativity is an essential part of the science discovery. I remember him once mentioning that he might have become a musician if he has not chosen chemistry, a reflection of the creativity that so vividly shapes his scientific vision. Today, he will speak on synergies for a brave new world, inviting us to envision how education, science, and technology can work together to shape a more equitable and sustainable future. Ladies and gentlemen, please join me warmly welcoming Professor Claudio Verani.
And it's projected only on that side. Yeah.
Do I need to use the mics? Probably yes, right?
Yes.
Okay. Let's see. Good morning. Can you hear me well? Excellent. It's perfect. Thank you. It is a distinct pleasure to be here today. It is an honor to be here today. I thank very much my hosts, and I welcome all guests to be here today. And when I was invited by my good friend Devi to come here and talk, she made one warning, that is, it is not about chemistry only, and I took that at heart. And that led me to think about another interest of mine, that is the intersection between science and philosophy, and the means of attaining science, society, and sustainability. Following the topic of this presentation, this is about synergies. Where is my pointer? Blah, blah, blah. If I use this laser pointer, can you see that well? Perfect. Synergies for a brave new world, and how we will need a concerted effort to build a positive, a productive future to all of us. Just because you might not be familiar with the University of Windsor, I want to show you very briefly an image of the campus. And this is Windsor, Canada. This is Detroit, Michigan, United States. This is Ontario. This is Michigan. And this is the iconic Ambassador Bridge that builds actually those two countries. Moving from that, this is the core of the university. This is the core of the Faculty of Science that also occupies several other buildings in there. And you're more than welcome to come and visit at any time. It would be a pleasure. I also want to thank Professor Devi Genehenege for the invitation to come here. The main organizing committee, it is not an easy thing to put together a conference of this size. It takes a lot of commitment, a lot of will, and a lot of determination to make that happen. So, in 1932, Aldous Huxley wrote a book called Brave New World. If you haven't read that yet, I highly recommend, because sometimes it sounds so present, so today. And there is the idea of a society in the future that lives on technological advancement and has created what seems to be a perfect world. There's no pain, there's no conflict. In fact, this is not utopian, this is a dystopian description of a future world in which individuality is completely erased. People are conditioned into groups, they have well-defined roles, they are kept pleased by consumerism. Instant gratification, and it adds up to the presence of a drug called Soma that keeps them in La La Land, happy. So, what is interesting to me, and what is interesting to many of the times that we are living right now, is that biology, psychology, and happiness are built not by force, not by oppressive regimes, but by technology and by chemical control. And this is where we want to be understanding what was going on in that novel, what is going on today, and how we need to synergistically approach and design and fight for a better future for all of us. Another part of this intersection between science and philosophy that I am particularly interested is the chemical reductionism. That is the idea of reducing complex events and behaviors and phenomena by the laws of quantum. I have some microphony. Quantum, atomic, and molecular theory. Why is that? Because simplifying things, reducing things, allow us to understand what is the core of the problem. An example of this reductionism can be given with the question, why there's life on Earth? Now, let's first of all discuss life, and let's define it as a carbon-based form that is self-sustaining. I think there's some microphone going on there. Thank you. Carbon-based, self-sustaining systems capable of harvesting energy and capable of evolving. Now, mind you, this is one way of describing life, and I don't want to be polemic going against any other way of describing life, but for this particular discussion, this is how I would like to see life. And the reason why we are here is because we have the right conditions. We have the reagents for that, the chemical reagents, plenty of carbon, plenty of hydrogen, plenty of nitrogen and oxygen. We have an oxidizing environment with oxygen that allows for electron transfer and electron transport that is necessary for that evolving of life. And then we have the right solvents. We have liquid water. We have a gas blanket that wraps the planet. And we have the right temperature and the right pressure. So life in this way, as wonderful and as divine as it might be, can be reduced to chemistry. And if I want to provoke just a little bit further, we can go further in that, and we can basically say that we can trace the thermodynamics of evolution. We are made of molecules. These molecules absorb light and heat, and as such, they become unstable. Excited electrons jumping around. And those excited electrons lead to some coalition of forming stronger, larger structures like proteins, like enzymes, because they are looking for some sort of thermodynamic stability. We have focused tendencies to characterize evolution, and humans require, and this is a very important part, humans require and rely on external energies to survive. In other words, we are very dependent on external sources of energy. And just to put things in perspective, because I really like this science, society, and sustainability intersection, the Earth was started at 4.5 billion years ago. Humans appeared around 200,000 years ago. And if we take those 4.5 billion years and we say, well, this is a one day, 24 hours, that means humans knocked on the door and started walking here mere 36 seconds ago. And in 36 seconds, we can trace a lot of change. So the idea then is that human evolution will need fuels and will need tools. The capacity that we had at some point developed to hunt and gather and to control fire allowed us to cook our meals, allowed us to have a higher intake of protein, develop our brains, and make what we are. There's a lasting need for fuel. There's a lasting need for new tools. There's the need of heat, of light, and later of electricity, transportation, storage. all of that is interconnected. Life is interconnected. So that in this regard, hunting whales for fuel and burning wood for fuel is just part of our living, of our being us. We can agree that we are burning maybe too many forests, as it was mentioned, but that is part of what it makes us what we are. And in this regard, we will be always looking for new sources of energy to maintain life on Earth. If we consider coal and petroleum, that can be also considered not completely positive at this point. It was positive in the sense that it allowed us to burn less forests and to kill less whales. So we are always evolving. The problem is that we don't always understand the limit of utilization. What makes us humans and what makes us act like viruses in those 36 seconds that we are occupying the main body that is our planet. The unsustainable use of energy and technology will lead to problems, will lead to many challenges. What I want to bring to this discussion here is that it also brings us opportunities. What will be called the labyrinths, some that we understand, some that we don't understand, that will require major creative thinking and synergy in order to find some of those solutions. And I will add another concept here, that is the reductionist view of labyrinths, the challenges and the opportunities that any problem brings to us. There's always challenges, but among or along with the challenges, we will have opportunities. The known labyrinth is the one that we understand. You see, we know that it's difficult to cross this pathway in here, but it is organized, and what we need to do is try to find our way out of this maze to the other place that technically will be a better place than where we are now. We just need to be brave enough to enter the labyrinth using the tools that we have at our disposal, finding for the solutions, getting to the other side that is better. Then there is the unknown labyrinth. And it's not a coincidence that I took the cover of Brave New World by Aldous Huxley here, because this labyrinth is much less defined. It is three-dimensional. It is not the usual maze that we understand. That means we have challenges, we have disruption, and we will have opportunities. We just don't quite know what they are yet. And that means, putting that into concrete terms, things like climate change, overpopulation, pollution in general, but plastic pollution in particular, those are the known labyrinth. We know what we need to do to fix the problem. Whether we have the energy and the drive, it's a different thing, but we know how to solve those problems. The unknown labyrinth brings all of those disruptive technologies that are coming right now, like artificial intelligence. And I agree with what was said. Artificial technology is emerging now, but it started a while ago. Quantum computing is starting now, will emerge full force in a few years. Robotics is happening right now, and even more and more. Molecular electronics, the final frontier. We will get to talk about those things. What distinguishes between the known labyrinth and the unknown labyrinth is that for the first, we have identified what are the chemical reactions that we can reduce the problems into. The unknown labyrinth requires new reactions that we might not be quite familiar with. And maybe it's not as simple as only one reaction. So, talking about the challenges and opportunities here, when we think about global warming, we can reduce that to combustion. And we do that all the time. We burn organic fuel because we want to seize the energy. That's why we do that. But in generating this energy, we are also building massive amounts of carbon dioxide. In fact, carbon dioxide, carbon monoxide, SOx and NOx gases, a lot of other things that are being generated in there. When we talk about overpopulation, we can narrow that down in a very reductionist way to nitrogen fixation. If we convert nitrogen that is aplenty in the atmosphere into ammonia, we now can have fertilizers. Fertilizers generate crops and food. Food allows for population expansion. And if we want to talk about pollution in general, but just for a second, fixing on plastic pollution, the reaction that best describes that is polymerization. So keeping those in mind and understanding that this reductionist model is an approximation like any other model that we could be using, we then move to think about what are the challenges and what are the opportunities in each of those scenarios. If we are talking about seizing energy because we need it, but also generating CO2, again, that combustion was involved in heat, light, cooked foods as we described, and then later explosion engines, machines that allowed us to thrive, enabled evolution, technical prowess, and populational growth. And that's where things start to become complicated, because it enables the good side of things and also the not so good side of things. We are now living in a time that we are producing 38 gigatons of CO2 from combustion and industrial processes just in 1 year, last year. And what that means is that as we increase the amount of carbon dioxide, we increase temperature. The opportunity here is to think about a way of having a better future, a sustainable future that is based on all sorts of alternative energies, solar, wind, and other tidal and other sources of energy. New synergistic ideas on how research, resource, and how to apply concepts that seemingly are not related to global warming at all, like catalysis, like photovoltaics, like the engineering processes that need to be related to that. And very important, the economics that are behind the development of those problems, of those solutions, sorry. When we go to the second challenge, that is nitrogen fixation as representing overpopulation, we can go back to 1909 when 3 liters of ammonia were produced in the lab. Ammonia is fundamental if we want to have fertilizers, if we want to have a strong agriculture, if we want to have sustainable food generation. This is absolutely necessary. There's no way around it. And just to see how important this process is, in 1909, 3 liters of ammonia in the lab. A year later, 22 tons of ammonia were produced industrially. Right now, we are producing about 725,000 tons of ammonia every year. And according to Václav Smil, who is a thinker in this particular area, he considers ammonia production as the detonator of population explosion. What are the possibilities in there? The main issue is that as ammonia increases, population increases. And as population increases, CO2 increases. global warming increases. You see, they are all interconnected. They are all entangled in a way that we really need to pull string by string to understand this broader scenario and then start acting on what we are talking about. But the opportunity that this gives us is a sustainable future with food security, with circular agriculture, in which we respect the land where we grow the crops, in which the land on its term gives back the food that we need. And new synergistic ideas will be absolutely necessary to imagine these biotech-driven ecosystems. And when we speak about biotech, I want to make just a small parenthesis in here. We are not necessarily talking about big tractors and huge fields that used to be forests. It can be made in a way that respects what was there before, respects the forests, and yet provide the food staples that we need to be here. It needs to be done in a synergistic way. When we think about plastic pollution and represent that by polymerization, this is a long-known process. Pre-Columbian cultures used to have caoutchouc to isolate things, to isolate and build materials. And in the development of this market, gutta percha, that is a resin from a specific plant, a specific tree, started to be used for insulating electricity, particularly the cables for telegraph in the 19th century that would be communicating the world. It was the first full expansion of communications across continents. The problem is that, again, there was not enough gutta percha to use in all of those cables. And as a consequence, Bakelite came in 1907. Research and development in plastic mushroomed in the 1940s all the way to the 1980s. And as a consequence, that explosion based on petrochemicals. Now we not only want petroleum for fuel, but also for plastic. And the bad news nowadays is that 400 million tons of new plastic is produced every year, and less than 10% of that is recycled. What that means is 90% of every plastic generated every year will end up in a landfill, in the ocean. There are these massive islands of junk in the oceans, and this is a problem. We do need to do something about that. So that in this case here, the opportunity is another sustainable future with biodegradable, recyclable plastics. There's a lot of research that has been done and a lot of research that needs to be done. Polymers that are as simple as the regular plastic polymers that we have, but now they have little carboxylate handles in there so that microbes can go there and chew in on that plastic. Those are wonderful opportunities. Self-healing materials that will actually find a longer utilization. New synergistic ideas need to be developed on how this molecular precision science will be developed, how this closed-loop economy will develop. And then, when we move from these things that we know how they work, there's still the need to have the will and the drive to solve those problems. But we believe we can solve them if we are only so determined to do it. And we move to what I call the unknown labyrinth. This is where new disruptive technologies will bring new challenges and new opportunities. We just don't quite know what will be yet. And we have two possibilities in there. We can accept our fate and say, well, nothing can be done, or we can really mold a better future. And following the great Canadian musician and poet Neil Peart, if you choose not to decide, if we decide not to do anything, we are still making a choice. It puts us in a very difficult situation, isn't it? Because if we decide that we are not able to change things, we are still making that decision. And the best way to approach those challenges, especially the ones we don't quite know what to do, is what I will call rebellion through education. Faculty here, don't be afraid. I'm not telling about any rebellion in the traditional sense, but it's the idea of education as a tool for non-violent social change, to challenge the structures and the norms that will lead us to a future that is not in our best interest, but actually to change that and challenge that towards a future that is, above all, more ethical and better distributed. What are those disruptive technologies? We talked about them already. Artificial intelligence. It is started in the 60s and 70s. It matured now. But in 2 years or so, if you look at the graph of the usage of the word AI, you will see that it goes 0, 0, 0, 2022, zoom, it skyrockets. And then when I talk to some faculty at Windsor and other places and I ask, how many of your students are using artificial intelligence? Oh, I don't think they are using it yet. Guess what? They are, in a daily basis, right? The question here then is to make sure that we know how to use artificial intelligence as a tool, not as a crutch, not as the savior that will allow us to do everything. But that is part of the challenge that we are having here. Then in a few more years, we will have quantum computing. That is this wonderful concept of moving away from binary language for computing, that is the yes and the no, the 0 and the 1, into interconnected states that are between that 0 and that 1. In other words, between the yes and the no, now there's the maybe. And that will make things look very different in the way we not only process all of the information that we have that is being already seized by artificial intelligence, but now putting it at a speed that is amazingly fast. Bring the next disruptive technology, robotics integration. So we are talking about immense amounts of information, super fast processing, and things that move around. And we start thinking about this kind of dystopian future that could happen, and that we have the key and the duty to prevent it from happening in its full force. And we find it cute to watch in our social media the little robots dancing, and a lot of that, by the way, is AI fakery, but a lot of that is real. And then the final frontier here is molecular electronics, that is to replace electronic components by single molecules or small groups of molecules. And those will be organically integrated devices. Now, am I giving you nightmares yet? We're talking about lots of information processed quickly in things that move around on their own volition, and they look more and more organic. So what will we do about that? I cannot reduce that to chemical reactions at this point. They go much further than the simplistic chemical reductionism that I presented the other problems. And what we need to do there is we need to, above all, feed, promote critical thinking. And the way to do that is a concerted effort, is an effort to build a positive and ethical future. We can't avoid the technology that would give something that resembles a robot that looks like a human. But we can teach ethics so that whoever is developing those machines knows where the limit is. And that takes a lot of effort by schools, instructors, and students. In other words, in this case here, schools, universities, professors, and students. Most of the students. This is synergistic. This needs to be, sorry, I'm of Italian heritage. I move my hands like this and I'm hitting this all the time. To build a positive future that involves all of us. So schools, universities, must become a catalyst for transformation, must be bold, reimagining academic programs. The programs that worked in the 50s not necessarily will work in 2025. We need to meet the demands of a changing world, and the world is changing fast. The choice that we have is, will we jump in or will we let somebody else do that? Fostering global collaboration. The borders are smaller and smaller. Fostering, like never before, an ethical curriculum that allows students to think about what is right and what is wrong. Empowering research, empowering both instructors and students to thrive in this very complex, very messy world that is completely interconnected. We need to think about programmatic reform. What are the important things that we want to teach our students? We need to emphasize critical thinking, problem solving, and ethics. We need to actually, rather than be afraid of AI, we need to have rigorous AI training, integrated translational curriculums, how we take things that look interesting in the paper, how do they work in, and I don't like this expression, but in the real world. Universities are the real world, by the way. We do a lot of real things here. But, you know, when students leave university, how will they work in their careers? Global partnerships. We cannot isolate ourselves. Promote experiential learning, the learning that actually is associated with the activities that will become important. Discuss employability and transferable skills. What universities need to do to prepare students that are ready for the market, students that are ready to find a job. Communication and writing skills. In a time in which Copilot can write our emails and our curricula and all of that, how do we make sure that us humans still hold things accountable? To me, very important is moving away from STEM to STEAM. In other words, science, technology, engineering, and math. Those are very important fields. They will remain relevant. But how do we now do science, technology, engineering, arts, and math? Because that will make us much better human beings. And just respecting time, I want to also include diversity and inclusion, and then move to speak about critically thinking our instructors. Faculty, and now I speak not as a professor of chemistry, but as a dean of the Faculty of Science. Our faculty are our most precious asset, right? Because they are doing the interface between the universities and the students that we want to train, we want to educate, we want to mold into productive citizens. They are at the forefront of this meaningful change. They serve as ethical compasses. And you see how many times I'm bringing you the word ethical, ethics here? Understand, they are role models that lead by example. It's a lot to be asked, and we need to be able to offer that, to support that. to understand, faculty need to understand innovation and exactly those disruptive technologies that we might be fearing right now. Have the courage to embrace change and to drive the narrative, because they will be shaping the mindsets, they will be igniting curiosity, and will be modeling and adapting what is needed for this rapidly evolving world. So to put that in words, we need to think about curriculum, what is relevant to our students nowadays. We need to think about interdisciplinary approaches, because if you are the most gifted mathematician in the world, you will be able to solve triple integrals by heart, but you might not realize that we can do something that actually is applied and is meaningful to much more people using those same triple integrals. Mentorship and guidance. We are going through a phase in which a lot of what we are learning, we meaning our learners are learning, is coming from social media. Needless to say, not necessarily the best source of education. Ethics and responsibility, I talked a lot about that, but it's the idea of embedding ethical reasoning in discussions that will shape AI, robotics, climate change, all of those topics, to foster responsible innovation. Use active learning strategies and digital fluency and global awareness and citizenship. We are citizens of the world. We also need to think about assessment reform, because in a time in which our students can come with a Google Glass that is connected to the internet, and we put a printed piece of paper in front of them asking to write the reaction of neutralization between HCl and NaOH, they will, if they don't know that already, they will be going online in real time, finding that solution and writing the solution, writing the response. That means we are not really trying to assess what they know. At best, we will be assessing their knowledge of technology, right? So how do we do things will change. The university of today and the future will look considerably different than what it has looked so far. And then the idea of well-being and resilience, of life balance, lifelong learning, all of that will become very important. And to my final two slides here, now what do students need to do in this brave new world? First of all, students need to step forward. You need to accept the challenge, and you need to accept that things are changing very quickly. Students will be the real agents of change. Faculty and schools, universities, will be the promoters of that change. But who will actually be the agent of change is the new generation that is here today, that will be here tomorrow. You need to critically engage with the pressing challenges of our times. Cultivate adaptable skills. Long is the time that we would graduate and we would find a job and be in that job for the next 30 years. That is gone. That doesn't exist anymore. You might be in the same place, but the nature of the job that needs to be done is changing. Embrace this lifelong learning idea and shape purposeful careers. And when I say purposeful, I don't want to say that we need to constantly be thinking about our next, although we do, we should, but it's a means of doing the best. If what we do is chemistry, let's do the best, most ethical chemistry we can. If what we do is drive a truck, let's be the best driver we can in that position. And that's how we build that society. Careers that are rooted in ethics and in their personal circumstances too. because every person is different. We need to have, that is exactly what Brave New World by Aldous Huxley wanted to eliminate. That is the individuality of the human being. And we cannot eliminate that. Of evolving opportunities, what is happening? How can we take advantage of that? So, last two slides, I promise. What do students need to consider in these new opportunities? Self-knowledge and career planning. Don't allow things to happen just by accident. Plan what you want to do. Understand what success means to you. Success means a lot of different things by a lot of other different people. So what is that for you? Based on your circumstances, based on your opportunities, where are your fortes, your strengths? What are your values that you don't want to sacrifice by doing some sort of career? Assess your strengths, your weaknesses. Think, envision, project where you want to be in 1 year, in 5 years, in 10 years, and work diligently towards that. I can guarantee that not everything that you plan and project will happen. But it is way better than relying on serendipity, that I've learned last night actually comes from the island of Ceylon. So relying on serendipity, on chance, to somehow mold our lives. Adapt, be resilient, embrace change, don't be afraid of any of that. My daughter, and of course you know me, I need to bring my daughter here, she's 21 and she has some friends that say, I don't like computers. And I think, how are you living in the 21st century and still saying that you don't like computers? So adapt, be willing to learn. And also another very important thing that seems to be outdated is learn personal organization and learn discipline as soon as you can. Understand the value of being organized, of being proactive, of offering your talents and being on time. The habits are really important to build trust, to build goodwill, to reduce stress. As somebody said, it is not the load that breaks your back, it's the way you carry it. And at a personal level, I think I can handle a lot of stress when I am planning, when I am actually controlling that, right? So this is very important and fuel long-term success. A positive attitude. Recognize and celebrate small victories. If somebody near you is having a victory, celebrate. Be joyful. It is very easy in the time that we live to be just down, to be depressed. Life is not fair. I don't have opportunities. And those might be true too. But how do we see things from a positive aspect? That is the challenge, and that's what I really want to invite the students here to think about. Hold on to that beginner's mind that I think it is one of the main goals of the Buddhist philosophy. Don't think that you already know everything, because we never know everything. How can we learn new things? And then critical thinking, inquiry, question assumptions, question, analyze data, try to find alternative self-evidence-based solutions. Make sure that everything that you're doing is ethical and cultural in terms of what is happening. Make sure that you work effectively across cultures and disciplines, and particularly for the Gen Z generation here, will be very important across different generations. Don't assume that the boomers and that the millennials are boring. The society has been built one step at a time. This is your time to change things, but also understand how that was built and integrate. The best companies, the best enterprises that are happening now are the ones that mix all of these different generations, Gen Z, millennials, Gen X, boomers, all of them working together. Because there's this wealth of expertise in there. Maybe the older generations have seen a lot, have run a mile or two. Maybe the younger in there will come with an unexpected solution. And that's exactly what makes this future bearable, right? And entrepreneurial thinking, take your good ideas and try to run with it. Environmental literacy, why do we need to change things in a way that we have been doing so far? Again, tech readiness is very important. Don't be afraid. And if you are like me and you dislike Windows 360, I'm with you on that. It's not the best system that I ever used, but it is what is available. So let's use that. And then if you have the time and the inclination, find a way to express your artistic self. It can be poetry, it can be music, it can be art, it can be dance. It doesn't matter. And maybe if you say, well, I'm not really artistic, well, sing, whistle. Because when we are doing that, art is one of the few things that will keep us connected with a world that wants to limit the connectivity that we can have more and more. So express yourselves. And just at this point, I think I have exploded all the time that I was allocated, and I really appreciate that. I will stop here, again, thanking for this opportunity to come here, thanking for this opportunity to be talking about not chemistry, but very important topics that hopefully, not particular this talk, but ideas that will shape a better future for us all. Thank you very much.
Thank you, Professor Verani, for that enlightening keynote. May I kindly request you, sir, to proceed to the center of the stage to receive the token of appreciation. And I kindly invite Professor Nanda Balasurya, the director of the PGIS, to present the token of appreciation to Professor Verani. Thank you, sir. With that, we take this moment to acknowledge our partners and sponsors whose support made Rescon 2025 possible. Gold sponsors of Rescon 2025 are Alumni Association of University of Peradeniya, USA Chapter, the Bitumix Private Limited. Our silver sponsors are New Lanka Cinnamon Private Limited, Lankem Robielac Paints Factory. Please direct your attention to the screen for a brief video presentation of our gold sponsor, Bitumix Lanka.
Mankind is gifted with petroleum in the form of crude oil. This crude oil is refined by a petroleum cracking process in which fuel oil and solvents are separated. The final yield in this process is a black-colored, semi-solid material called bitumen. Bitumen has excellent chemical and physical properties such as binding, waterproofing, insulation, and UV protection. As the name Butamix suggests, Butamix specializes in manufacturing varieties of butamin mixes using the inherent chemical and physical properties of butamin for construction and engineering applications.
Thank you. We also thank the Alumni Association of University of Peradeniya USA chapter for their gold sponsorship in making this event a success. To introduce our second keynote speaker of the day, may I invite Dr. Lakshita Pahalagedara, the Dean, Faculty of Postgraduate Studies and Research, Sri Lanka Technological Campus, to introduce Professor Veranja Karunaratne, Vice Chancellor, ESOFT University.
Good morning, ladies and gentlemen. It's a great pleasure and honor for me to introduce the second keynote speaker, Professor Veranja Karunaratne. Professor Veranja Karunaratne earned his BSc Special Degree in Chemistry with first-class honors from the University of Colombo, Sri Lanka, and his PhD in Synthetic Organic Chemistry from the University of British Columbia, Canada. His distinguished career includes serving as a chairman of the National Science and Technology Commission, council member of the National Research Council, and head of the Department of Chemistry of University of Peradeniya. He was also the chairman of the National Intellectual Property Commission and a key founder and leader at Sri Lanka Institute of Nanotechnology, SLINTech, where he held roles as science team leader, an associate director, science and strategic relations. Subsequently, he served as the vice chancellor of SLINTech Academy. He also served as the vice chancellor and the chief executive officer of Sri Lanka Technology Campus. Currently, he serves as the commissioner of Sri Lanka Inventors Commission and the vice chancellor of ESOFT Union. Professor Karunaratne demonstrated a profound commitment to academic research, administration, leadership, and national scientific framework. Professor Karunaratne is a fellow of the Royal Society of Chemistry and the National Academy of Sciences, and was honored with the Chevalier d'un Laureate Palme Academique Award by the French government in 2012. Professor Karunaratne has authored over 200 peer-reviewed papers and holds 17 patents and supervised number of PhD and MPhil students. So I would like to welcome Professor Viranja Karunaratne to the stage. Thank you.
Very good morning to all of you. Lakshita, thank you for coming all the way from Colombo to do this. I appreciate it. Lakshita was an undergraduate student of chemistry and a PhD from University of Connecticut not so long ago, and I had the honor and the privilege of working with him at Slintech some time back, and we also shared the same space at SLTC some time back as well. Deeply touched by your kind words. So I thought of talking on a topic of research. Since the two previous speakers, Vice Chancellor certainly gave a very rosy good news scenario of science and technology at Peradeniya. That is true. There are always two ways of looking at the same object. Looking through the same window, one sees stars and the other sees mud. Not that I'm seeing mud, but I want to tell exactly how it is, how we do science in this country. So let's go to the beginning. In about 800 BC, in central Greece, there was what is called a Delphic oracle, where the goddess or the priestess Pythia would take your questions and give it to God Apollo and find answers and tell those answers to you. Unreliable, of course. Pythia's answers were sometimes doctored, not quite what Apollo, the god, told her, but that's the best they had at that time. But inscribed on the Delphic oracle are these words: know thyself and nothing to excess. Know thyself and nothing to excess. And upon these, all other precepts depend. So let us know ourselves first. Who are we in science and technology? It's good to self-examine how and from where we do research. So this is how it looked. Comparison of percentage expenditure on education to GDP with the percentage of expenditure on higher education and GDP. Up there is those percentages. 2% of the GDP from 2015 hasn't changed much till about 2021. 2%, of which 0.5% given to higher education hasn't changed also. So the 100 million that our kind Vice Chancellor told that the University of Peradeniya academics will receive is also part of that 0.5%. There are no other monies coming from anywhere else. That's the 5% we have. So this number remains stagnant, and much of these amounts are taken as loans from foreign governments. So when we say free education, it's really not free. The kids, there are some undergraduates, I keep telling them, my current undergraduate students, look, it's your grandchildren who will pay for your education. Very lucky generation that you are. Your parents support you and feed you, and your grandkids pay for your education. How wonderful. So let's go. Comparison between percentage number of all candidates eligible to enter universities with actual percentage number admission to universities and the eligible students each year. If you look at the top, the number remains very stagnant. 2016, 62%, 2021, 62%. How consistent can you get? Then at the bottom we have what's the percentage we admit. Top is the percentage passing, bottom is percentage admitted, 19, and in 2020 it went up slightly to 2022, and in 2021 it increased to 25%, and the state universities admitted about 43,000 students. That's where we are. We seem to have hit a bottleneck beyond which we are unable to proceed. And then where do the other kids go? So here is the number of admissions. Western Province admits 11%, admitted 11% in 2020, 2021, although the GDP of the Western Province is 43% of the country. Admits roughly 11%. Equitable, yes, across the provinces, thanks to the H-index, thanks to the Z scores that I applied right across, but there are lots of bright kids who are denied access to universities from Colombo. And if you ask me to be the CEO of a country where I deny access to bright kids to university, I wouldn't be the CEO, right? You can't run a business that way if education were to be a business. And it is. It is for the development of the country, right, which brings in money. But where do the other students go? 43,000 to state universities. Now, the non-state sector, where I work today, which I wanted to make a change and see how the non-state sector can contribute to national development. I was at one for 2 years, just long enough to make the campus profitable and make the campus what we think ought to be, and then I moved to another area, other campus, and the numbers there have grown. It was 25,000 in 2020, as opposed to 43,000 in state universities. And that number, although the state university numbers have not grown, the private sector numbers are now standing at about 35,000 a year. Do these kids find jobs? Of course. Private sector overwhelmingly prefers to hire students from private universities because they graduate on time, 4 years and 2 weeks, they're marching in the convocation. There are no strikes. There is no student unrest. Parents love this. Private sector who employs them welcome them through open arms. And they are also Sri Lankans, if there was a doubt that they were not. And they do get ahead in life as well. Let's come to the R&D sector. I gave you an overall view of how things are. Let's come to the R&D sector. These 2022 statistics from NSF tells us that the about 0.1% of the GDP is spent on R&D. Just 0.1%. That's the amount. That's how every one of you mostly get your money to do research. That's where, as the Vice Chancellor said, that University of Peradeniya academics publish 400 papers in cited journals out of that money, mostly. And that money doesn't go to the private sector because the private sector is not eligible to receive research funding from the government. Only state universities are. So you can see the sectors where the government sector and where the funds are coming from. and the business sector, how much they contribute, and a higher education sector, how much they contribute towards this research. So much of our money is yellow, meaning it's capital, right? It's recurrent, I beg your pardon. So much of the money we receive is recurrent, salaries. Vice Chancellor, although he didn't tell you, it is a fact that 95% of the grant of approximately 1.2 billion that the University of Peradeniya receives, 95% goes to pay salaries, right? So, fine. I'm happy that he's giving 100 million for research, but that's just 250. That's barely 250,000 US dollars. There are at least 5, 6, 7, 800 academics here who would like to receive that money. It's not a happy situation in that sense. So you can see how the basic research to applied research to experimental development is also divided. Not that, I mean, I'm not blaming any government per se. This has been the case for as long as you can remember. So no single government is responsible for this. Everybody seems to have thought that spending money on research is like putting money in the bank. That if you put money in the bank, at the end of the year, you get interest. So research must yield interest at the end of the year. So that's the hypothesis of the Treasury. You ask the Treasury, they're impatient. Why the scientists are not producing money, commercializing inventions fast enough, like how the banks produce money and give you. You couldn't be further from the truth. Life doesn't work that way. Research doesn't work that way. Sri Lanka, there it is. Gross domestic expenditure on research and development, good. Sri Lanka is at 0.12. I've slightly added a 2 to the second decimal, just to make it look good. India 0.64. And India's difference is, the first Prime Minister, Jawaharlal Nehru, put it in the constitution that India will spend so much for R&D. The difference between Sri Lanka and India at the time when the British gave over the two countries, Jawaharlal Nehru, Prime Minister, was a technocrat. And they have hugely benefited because their first Prime Minister was a technocrat. Our first Prime Minister, I don't want to say bad things about people who are dead, but he was a Colombo 7 farmer. He took it upon himself that farming was what we needed, where Sri Lanka at that time was agriculturally totally self-sufficient. So you can see where the two countries are now. Beginnings define the future paths, and there is no better way to look at it than compare India and Sri Lanka. Global average is about 2%. Global good is 3 trillion, and 95% of those 3 trillion come from the top 20 countries in the world. That's a fact. The number of patents, I was once the chairman of the Intellectual Property Advisory Commission in Sri Lanka, which is the apex body to NIPO, which is the National Patent Office. So the number of patents have remained with a resident application. That means Sri Lankan applications at about 80, number of non-resident at about 110, and this number has not changed significantly over the last 10 years. It continues to be the same, right? So which means the 110 is foreigners who have applied in the US and in other countries are doing a country filing in Sri Lanka. That's 110. So the real Sri Lankan patents are 80. And at this time, I will go to publications later. So this is where we are, 89th in the Global Innovation Index. India from 60 in the last 5, 6, 7 years have increased their Global Innovation Index to about 36 now. They've gone up quite a bit. If you look at The basic requirements, the Global Competitive Index looks at a number of factors. It's the factor-driven economy, efficiency-driven economy, and innovation-driven economy. In the first column, the factor-driven economy, Sri Lanka has everything in it. 1, 2, 3, 4. All of that we have. In the second, efficiency enhancements, the first pillar, higher education and training, we seem to have it. There are a number of things we don't. The technological readiness, we seem to be okay, but there are a number of pillars we are not. And in the third pillar, innovation and sophistication factors, sub-index, business sophistication and innovation, we don't score high marks in those areas. So we can see why we are 89 in the innovation index. Remember my first slide? Know thyself, and know only that. There's no need to know anything else. So, publications. In 2014, actually it was the year 2000 that the NRC started giving awards for research publications, President's Awards. We were there at that time. So 2014, we published 669 papers, blue for 100% Sri Lankan authors, yellow for mixed authorships with foreigners in it. Either way, we have published 669 papers. And that number seemed to have increased to 2,528, both foreign and non-foreign participation in 2020, and this number continues to grow. So this is a miracle in Sri Lanka. This is a happy miracle, right? Remember, I'll come to that later. So this is a great thing. So the staffing, we all know that. Although we are told we have about 4,500 scientists in various sectors, including academia in this country. New PhDs are at the bottom. The numbers are very difficult to retain. Many of our undergraduates leave the country never to return. And retirements, resignations, particularly in the last few years, people between the age of 35 and 45, many academics left the country. So that's where the staffing situation is. So my title is The Road Not Taken, adopted from the poet Robert Frost, who said, 2 roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. It appears Sri Lanka also confronted 2 roads at a point in time, maybe after independence. We seem to have gone down the cheap, well-paved road and yielded very few results. We seem not to have taken the harder road of investing money, finding money for research, and making research possible. We don't seem to have gone down that path. So let's go beyond. The true test of a champion is not whether he can triumph, but whether he can overcome obstacles. Can we, or do we, as academics, constantly challenge us to overcome obstacles? Is that how we do it? There are academics who do that, and there are those academics who have flown out of the cuckoo's nest, in spite of the bad indicators that I've given you. There are many academics who have flown out of the cuckoo's nest and forged a career for themselves and done extremely well in research in this country against a backdrop of very little support. So let's come to that. For those who are delusional enough to forge their own path to a life spent on R&D, there are many in this audience who are delusional to forge a life of R&D. Still, many obstacles remain. It's still not an easy path. And let's discuss some of these obstacles that you have faced yourself. The Matthew effect. The rich gets richer and the poor gets poorer. And that's true for science as well. It's a centrifugal effect. high journal rankings are self-perpetuating. Hard for new journals such as the Journal of National Science Foundation to break into high rankings. Very hard. Non-English language citations are undercounted. We know that. Those who have power and economic and social capital can use those resources to gain more power and capital. That's Matthew effect. That's true for science as well. Matthew effects operate in other areas also, not just journals. Difficulties of publishing research from a developing country, with a Sri Lankan address, where the editor who first receives your journal, sends it past for review, it's a great achievement, because 50% of those submissions are rejected at the desk because of the Sri Lankan address. We all know this. We have faced this situation time and time again. An equally important problem is that research carried out in developing countries lack visibility. Nobody notices them. Nobody quotes them. We are undercited. If there are 2 publications that are citable for a given topic by an author, if he sees a Sri Lankan address citation versus some other country citation, he's very likely to pick the non-Sri Lankan citation in his references. So let's have some humor about this. Some of you are old enough to have read the cartoon series Peanuts. I certainly have. I'm old enough for that. Many of you haven't. So Peanuts has submitted an article to the magazine, and he has received comments from the editor. Thank you. It says, thank you, Peanuts, for submitting your story to our magazine. To save time, we are enclosing 2 rejection slips. One for this article and one for the next one you submit. How many of you have had heartbreakers where you have maybe once in a lifetime submitted to journal, Nature something, and where you have rebutted all 3 reviewers, but successfully, you have rebutted all 3 reviewers, and one of them at least tells that that's fine, you have rebutted well, but I still reject your paper. Those are heartbreakers. Takes months to recover out of, and that's what we face every day. How about research grants? The Vice Chancellor is so kind to remind us that there is 100 million in the kitty. There is this joke. I asked Santa for a research grant. So the other guy says, do you still believe in research grants? He doesn't say, do you still believe in Santa? Santa is more realistic than a research grant. The second, this applies to people in plant and animal sciences. Sorry for the joke. It says, if we get this grant, we might be able to afford real microscopes. So, sharing scientific knowledge. We are told that if you haven't published, you haven't done any work. We are told that. You need to publish, right? From the time of Isaac Newton, who presented Principia to the Royal Society, we have published. That's how Isaac Newton became very famous. Maybe there were other scientists who had done similar work, but didn't beat Isaac Newton to go in front of the Royal Society. So, science is shared knowledge, yes, and it says most scientists today, this applies to Sri Lanka, regard the new streamlined peer review process quite an improvement. You can see the guy is going down the path to publication, and how many people are waiting with swords, rods and everything to hit the guy, and at the end, if you beat all of those, it says paper accepted. If you can beat all that, the paper is accepted. So With all this, then the question is asked, are we delusional to live and publish and work in Sri Lanka? Of course we are. Otherwise, we wouldn't be doing this. Sometimes delusions lead to success. You've got to be delusional. So, I just want to talk about one thing, and here with your faculty, although all of you, many of you who are here are known to me, I may as well say this while having a meal with you. I don't need to come here and give you a keynote speech. So some of you might wonder what I did at the Sri Lanka Institute of Nanotechnology. I have done a lot of research in my life in many areas, but the one story that I can tell my grandkids is this. There are many, but you must remember your grandkids also have a very short attention span, so you got to only tell them one. This is it. So when we were released from University of Peradeniya to work at the Sri Lanka Institute of Nanotechnology, Slintech, in 2008, I got a letter from the Minister of Science and Technology, Professor Tissa Vitarna, saying that I've been released from the university for national duty. I don't think any one of you have ever received a letter saying you are released for national duty. So we were told it's a public-private partnership. We were fixed in a garage in the Biyagama promotion zone in a factory basement belonging to Mars Holdings, and which they had summarily, very quickly partitioned into labs. And we were told that we give you 3 years to come up with products in nanotechnology for sale. And if you don't do that, this experiment, because it's in a garage, no Sri Lankan will ever know that you are here. You are free to go home. No one would know that you were even here for 3 years. So we had 3 years. We set out our own rules of operation. We had 2 rules. I was appointed as the science team leader. One rule was failure is not an option. Everywhere we had signs for scientists to see. Failure is not an option. The RFT, as I call it, RFT is the right first time percentage. Your RFT has to be 98%. You have to get it right the first time, or there are no second chances. We had no meetings where we call scientists. All meetings were abandoned. All approvals were given in the middle of the night through email. The meetings were only management meetings. There were 0 meetings, except progress meetings. So the company ran with no vehicles, no push bicycles for anyone to go in. You drive your own car. You write a letter, you make sure the letter gets a result that it wants by yourself. There's no one to help you here. We had no peons, no one to make tea for us. 0. So, in this climate, I want to tell you the story of one of these projects which became a success, where we made a precision release fertilizer for smart agriculture. And Professor Virani was talking about sustainable agriculture here today. A tale of green discovery from Sri Lanka. Just to show you that it is still possible, this was done at Slintech. So we know that the food production is a difficult conundrum, right? 50% of the Earth's habitable land is already taken for agriculture. It's a difficult issue that we have to confront. And agriculture is the primary driver of deforestation and habitat loss and biodiversity loss. Humanity would require more food in another 100 years, 80% more. Global food system is the single biggest contributor to climate change. Although we think it's fossil fuel, but fossil fuel is also in it. And a third of all greenhouse gas emissions. The number of people suffering from hunger and malnutrition has been increasing in step with the global population since 2014. So, how did we get here? How, at the turn of the last century, this is how it looked like. We got there, and at the dawn of the 20th century, humanity was facing a global disaster of mass starvation. Long predicted for the last fast-growing population was about industrial revolution had begun. Many jobs were available, but food production was lagging behind. And the world scientists were asked to find a solution, and the two chemists who saved the world from hunger was Bosch and Haber and Bosch, who both received Nobel Prizes, one a number of years apart. For chemistry though, one was a chemical engineer and one was a chemist. So the production of ammonia, thereby adding one carbon atom to ammonia to produce urea, became possible, and we were sustainable. So one of the biggest issues of fertilizer is that urea is highly soluble, so is potash. NPK is still required by plants, and phosphorus is so insoluble that it gets stuck in the soil. So we were asked by Haley's Agro in Colombo, the company who had invested in Slintech, can you make a slow release fertilizer for urea? Now, come on, I'm a chemist, right? The word fertilizer was already not too familiar to me. We quickly became champions of agriculture, although we didn't know anything about agriculture at that time. And we looked quickly in 2009, the patent scenario for slow release agricultural innovation patents were less than 400, but for slow release drugs, there were over 6,000 patents. We seem to think that taking medicine is better than eating. So that was the investment level at that time. So we knew we were kind of, this is an impossible task. How do we overcome all this? So one of the team members, who is not in Sri Lanka, she's a professor now, at that time she was a doctor, Nilwala conceptualized a crazy idea, which is, can't we use hydrogen bonds? Because urea has nitrogen, urea has oxygen, can't we use hydrogen bonds to slow its release? How do we do that? So we turned to nature, and nature, we know the bones are composed of hydroxyapatite, biomaterial. So we said, okay, let's make hydroxyapatite nanoparticles and put urea into it, and then it'll form a hydrogen bond between them, like how it is in water. So that water had hydrogen bonding, we knew from our A-level chemistry. So this innovation, the concept of this innovation is just A-level chemistry, nothing else, right? Used in a crazy way that it finally worked. So we thought hydroxyapatite nanoparticle, which is very surface reactive, because the nanoparticles, one of the characteristics is that they are surface reactive because their functional groups are all on the surface. So the OH groups on the surface would bond, hydrogen bond to urea, hydrogen bond to urea, and we throw it to the soil, to acres and acres of land, and hope that it is released slowly. We did apply immediately. In 2010, we applied for 2 US patents. By that time, I had become the IP manager also. I had got tuition from our IP lawyers in New York, Alston and Bird, to give me tuition for 100 hours, we'll pay for it. I wanted to become a patent writer because I wanted to do all the office actions myself, or at least be in the action when the office actions are coming. So what we did was, we did make hydroxyapatite and added urea into it through a salt gel method. And the ratio between urea and hydroxyapatite was 1:1, just 1:1. And the nitrogen percentage in that urea was 19%. What is the nitrogen percentage in urea? 46%. So this is way low. Cannot do it. So these 2 patents, just so that we were so naive, so intensely wanting this to succeed, we took that hydroxyapatite coated urea and put it into Gliricidia sepium wood chip barks so that it will be even further slowly released. And we took montmorillonite clay and put it into clay and thought it will be even released slowly, and these are the two patents we applied, and both patents were granted 3 years later. And in fact, so I'll tell you the story. So when we wanted to publish this work, chemicals inside wood chips, is that science? So all the European journals scoffed at it. They laughed at us, saying, what kind of science are you publishing here? Right? Wood chips, we have never seen wood chips ever. The word wood chip in this journal has never been used. So when all European journals rejected our papers, we turned to our good old Indian Current Science journal. Current Science was fashioned after Nature. They publish a journal, one issue per week. So I still remember writing this myself, every word. And I said, in this paper, we describe a strategy for sustained release of nitrogen into soil. Specifically, urea, modified hydroxyapatite nanoparticles were encapsulated under pressure into the cavities or nano cavities of a soft wood of Lyricidia sepium. So that was the first paper. Later we published the montmorillonite paper as well. So lo and behold, now this was published in July 11, 2011. I get a call on the 20th of July, 2011, in the afternoon at 2:24, I noted the time. Professor Karunaratne, this is Dr. Panibrata Pandey from Nagarjuna Fertilizer of India. We've seen your paper, of course. The guys who are scanning their own papers. And we want to buy your technology. So I was wondering where the closest chair was for me to sit. I never heard those words in my life before. So I said, okay. I was lost for words, but somehow I managed to say a few words. He said, in 2 days, I'm going to send you the deal in terms of money. So in 2 days, get an email saying, we are going to pay you initially $1.5 million. My God, I thought, is it rupees or 1.5 million or dollars for this? But see, you have put six OH groups on the nanoparticle. That's a picture. That's a picture. That's not the status. We don't know whether there are 6 molecules per OHs per nanoparticle. So he's seen this. He says, no. So I want to say fortune favors the brave, and we were brave. We believed in that naively. I must say, we believed that we could pull this through. Just by the sheer grit that we had displayed. So Panibrata Pandey said, yeah, 1.5 million initially is there, but you got to jump the valley of death. Valley of death, you got to jump. So I said, what is it? So he came to Sri Lanka. We took him to the board. He talked to the board and said he's interested in buying. But to me, he's saying, this is your valley of death. We don't want any wood chips. We don't want any montmorillonite clay. Throw them out. We want just your hydroxyapatite urea nanoparticle because it's too costly for us to transport wood chip because remember, agriculture receives almost no research funding compared to other areas. It doesn't receive anything. So he said, transport costs are too high. Throw away wood chips. Throw away everything. Give us the nanoparticle. And remember your picture in that paper, it had 6 OH groups. So you have to make the ratio not 1:1, but 1:6. And he said patents must receive approval before the transaction is done. Fair enough. I mean, that was okay for us. So the problem with 1:1, making it to a 1:6 was the moment we added more urea, because we were air drying the fertilizer. We added salt gel, we air dried, 1:1 perfectly air dries to give you a nano system. The moment we increase urea, the urea crashes when we air dry. So 1:6, impossible. It was totally impossible and it crashed. We were not making it. So there were many who contributed to the project that I will give you. Now, one postdoc, a PhD student of mine, Dr. Asita Sirivardhana, we had discussed how to overcome this. So he suggested that maybe we should flash dry this. Flash dry it. When you quickly dry the system, not air dry it, a metastable system might stay together, which is what he was doing one afternoon when I was walking around the labs. He had heated a frying pan, Teflon frying pan, and the guy was spraying with a paint sprayer the hydroxyapatite suspension onto the frying pan. It was at about 100 degrees. Solid particles fell down. We checked the SCMs, we checked the TEMs, 1 to 6 perfect nanoparticles. So we had jumped. We had come out of the valley of death. So the patents needed to be approved now. So we did a patent search immediately, and lo and behold, patent search came out, 0 hits for this thinking. No one in the world, no human in the world, no scientist in the world had ever thought of using the hydrogen bond to make a fertilizer, slow releasing fertilizer. So Sri Lankans said, we could do it. We proved time and time again we could do it. So then, in the next 12 months, we did apply for a patent there. We did we threw away our wood chips and MMT, and we made the fertilizer. For the next 12 months, I made 12 trips to Hyderabad, which is where their head office was. 12 trips. We had a team of about 18, 15 scientists working on this. So of the $1.5 million he promised, he gave us immediately $0.25 million for us to do the research that he asked us to do, to jump the hurdles. So, which was very useful. And I made 12 trips. So the first trip, this guy, chief scientist, he took me to a corner and brought his chairman and started quizzing me on chemical kinetics and thermodynamics. I'm an organic chemist. So fortunately, Sri Lankans, as you would know, Professor Virani, their undergraduate degrees are impeccable, right? There's nothing that they don't know. So my kinetics knowledge, after decades of not thinking about chemical kinetics and thermodynamics, was good enough to pass the tests that he gave me and quiz me. So, okay, the senior scientist looks credible enough. The guy is not a joker. So let's now hear it out. So I would take 2 of these inventors at a time on trips, and my wife would attest to you that I did saris, buy saris every trip. But the time spent to buy saris was like 5%. And she never complained about the salwar kameezes that I bought also. I think they were horrible, but she never complained. So I would take them. So the last trip, 12th trip, when I took to Hyderabad with this Dr. Asita Sirivardhana, who did the flash drying, the guy was quizzed so hard. The CEO would come to his ear like this and ask him questions that I didn't hear what was being asked. The Indians wouldn't part with their money easily, and I think Professor Virani would know this. Indians are notoriously stingy at giving their money away, right? So it was done, but one thing Asita didn't tell me is that he hadn't slept in a week. He hadn't slept in a week. So we were taken to Secunderabad Club, one of the old British clubs left behind in Secunderabad or Hyderabad. And Asita seated next to me. They offered us 2 drinks. Asita took the first sip and he collapsed. So I will tell you how I dealt with it, probably over a drink in the evening. I don't want to waste your time. But by using appropriate and timely action, I corrected the situation, and the next day we flew back to Sri Lanka with $1 million arriving through mail, through bank transfer. So that is how we did it, and this is our second patent. We applied in 2012 and we got it in 2014, and now journals are flocking to accept our papers. We don't have wood chips in it anymore, right? So this is a This is a high impact journal, SES Nano, barely got rejected from Nature Nanotechnology. I told you the reason. One reviewer didn't believe that we could do this out of Sri Lanka. That's the only reason. There's nothing else to it. But we are prepared. So it worked on field trials. You can see no fertilizer on the left, normal fertilizer on the middle, and 50% of the nano fertilizer on the right. 50% of urea gives a better yield. Again, I'll tell you what happened to this. So we built a mini plant, and this is the team who did it. And by that time, the government was so confident in our scientists' work, because we were told, you are history in 3 years if you don't make something out of this. You are history. So we had proven them wrong, and they built a big nanoscience park, which is Slintech today. I feel quite happy there. And these are the guys who did it. Many of them have gone on to get their PhDs, and many of them are professors, in fact, here. One in chemical engineering, Dr. Nadish, who is a professor now, I believe. Dr. Nilwala became a professor. Asit Gayan Priyadarshana is a professor. So this has been a long coming, and we proved that if, every time we applied for a patent, I would be like the soccer coach. We would do a group huddle. That's the culture we built. A group huddle among the scientists. We held each other and encouraged each other and said, this patent is going to get approved. Those were the methods that we used in getting this done. So finally, I want to come to my own faculty here, to Peradeniya, to Sri Lanka, or University of Peradeniya. In spite of the poor numbers that I gave you earlier, dismal numbers you might even say, some scientists have flown out of the cuckoo's nest. Some have excelled in this faculty, and they continue to excel in this faculty, regardless of what the ground conditions are. So there are plenty of miracles happening in our midst, plenty of miracles. It's like, if you ask what is the theory of the Faculty of Science, like what is the theory of general and special relativity, the assumptions. Einstein made some assumptions that he never explained. The speed of light is a constant, right? All physics that applies to inertia systems is the same. He never explained them. So, the Faculty of Science, the theory of Faculty of Science is the biggest miracle. Miracle number one that cannot be explained is you, the faculty. There are over 100 PhDs here. That's not supposed to be here. You're not supposed to have 100 PhDs here, if those numbers that I told you are right. But you are here. It's a miracle. And of those, I'm told by your good dean that the large majority are young, under 50. So the future is really bright for all of you. And the second miracle that I see, other than you, is the undergraduate degrees you produced are the envy of the world. Are the envy of the world. In spite of all these difficulties, you do make some miraculous things to happen. So those amongst you who are delusional enough to engage in research, work hard and let your work speak and not your voice. And one day you will see the bright sun rising over the Hantana mountain, and then you will know you made it. And then when you made it, be humble to acknowledge that you have made it. So the number of people that I want to thank, my PhD students, there are over 24 PhD students, MPhil students, another over a dozen, postdocs and research scientists and RAs that I met both at University of Peradeniya and at Slintech. Together we spent over 200, I wouldn't call them man years, I would call them human years. Avoid the word man. We have spent over 200 human years sharing our lives and doing science. which has really, being a miracle, there is not a day that goes by that I don't get a call from one of my PhD students. 24 of them is a lot, and each one, you know, how I spent these times and how I did everything, I really don't know, but I'm standing here is evidence enough that I was able to do everything. And I am also privileged that I was able to teach 1,000 plus undergraduate chemistry special students over the years, to whom I'm greatly privileged to teach the art of synthesizing organic molecules for over 30 years. I hope they got something out of it, and they will continue to take that wherever you go. And those students who came to me before they left to the US, as you know, chemistry is a field, physics, molecular biology are fields where they're immediately grabbed by the US for their PhDs. So they would come and tell me that I'm returning after my PhD. So when they see a smile on my face, they know that I don't believe them. Then they start crying. You don't believe me, sir? I said, of course I believe you. But can you send me an email in 2 years that you're coming back? I'm still waiting for those emails. But they were forgiven. From the moment they made the promise, they were forgiven. I knew they would never come back. So, and finally, my wife, who today too, she dropped me in a God-forsaken place in front of the biology building, and I just ran and joined the procession. That's what she has done. She drops me in various places and expect that I would come back home in one piece. For a decade and a half, I worked 7 days a week. I worked 5 days in Colombo at Slintech. I did all my undergraduate lectures in the weekend and supervised my research students in the weekend, 7 days a week. And my weekday ended at 6 o'clock on Sunday evening. And then off I go to Colombo again at 5 o'clock. So if you're happy in what you do, probably entropy doesn't affect you that much. I'm thankful for that. The organizers, Devi, who is my colleague, who came from University of Ruhuna 20 years ago, been a super organizer at whatever she does. She got me to obey to every rule she put in front of me, and send the abstract on this date, send your slides on this date, all that, and I obeyed. Thanks, Devi, for organizing this. Thank you for the organizing committee. Thank you for all of you for listening. Yeah, good day to you. I'm sorry I cut into your tea time.
Thank you, Professor Karunaratne, for that inspiring looking keynote. And may I kindly request Professor Sanath Rajapaksa, the Dean of the Faculty of Science, to present the token of appreciation to Professor Karunaratne. Thank you, sir. It is now my pleasure to invite Professor Manava Devi Ganehenage, the chairperson of Rescon 2025, to deliver the vote of thanks.
Ladies and gentlemen, as we come to the close of this wonderful inauguration of Rescon 2025, it is truly my privilege on behalf of the organizing committee of the Postgraduate Institute of Science, University of Peradeniya, and as the chair Rescon 2025, to extend our heartfelt thanks to everyone who has made this morning such a memorable and inspiring beginning to our annual Research Congress. First and foremost, we are deeply honored by the presence of our Vice Chancellor, Professor Terence Madhujit, who joined us despite his many commitments. So I'd like to thank him for gracing this occasion, for his inspiring words, and for his continued support to the Postgraduate Institute of Science. Our warm thanks also go to Professor Sanath Rajapaksha, Dean of the Faculty of Science, for being with us today and for your constant encouragement. We are privileged to have as our chief guest Professor Jayantha Gunaratna, Senior Principal Investigator at the Institute of Molecular and Cell Biology, A*STAR, Singapore. Professor Gunaratna, your remarkable journey from the Department of Chemistry at Peradeniya to your current global standing, along with your international recognition, is an inspiration to both our young researchers and all of us. Thank you for taking the time and effort to be here, for your motivating address, and for bringing such pride to the University of Peradeniya alumni. Our sincere appreciation goes to our distinguished keynote speakers, Professor Claudio Verani, Dean, Faculty of Science, University of Windsor, Canada, and Professor Veranja Karunaratna, Professor Emeritus, University of Peradeniya, and the Vice Chancellor of ESOFT University and Slintech Academy. Your thought-provoking addresses have inspired us to view science through the lenses of collaboration, creativity, and responsibility. A special word of thanks to Professor Claudio Verani, who traveled all the way from North America to be with us. Beyond your inspiring keynote today, your efforts to initiate collaborations between the University of Windsor and several Sri Lankan universities, including Sri Javadanapura, Kelaniya, Colombo, and Peradeniya, are deeply appreciated. We also warmly thank our plenary speaker, Dr. Dushanti Disanayaka, for joining us and for enriching the Congress with her expertise tomorrow. Our deep gratitude goes to Professor Nanda Balasuriya, Director of PGIS, for his unwavering support and guidance, which made this Congress possible. My sincere thanks to Dr. Gajaba Ellipola, his tireless efforts in Gajaba Ellipola, the Secretary of Rescon 2025, for his meticulous coordination. And also Professor Namal Priyantha, Editor-in-Chief, for his tireless efforts in editorial and sponsorship matters. And our associate editors, Dr. Subhashini Gunatilaka and Professor Shanika Kumburigama, for their dedication throughout the process. A special thanks also to Dr. Tiloka Aryasena, Editor of Research Highlights, for her excellent teamwork. We also extend our appreciation to all organizing committee members. You can see the members there, because I can't name everyone, so I just prepared this slide. And team coordinators, session chairs, reviewers, conveners, and the many subcommittee members whose teamwork ensured the smooth organization of this event. Our gratitude goes to the Young Researchers Forum for their enthusiasm, and to the media, publicity, and technical teams led by Dr. Manjula Vijayasinghe and Mr. Rusit Pilapitiya, Ms. Samadhi Rajasinghe, Mr. Isira Ratnayaka, Mr. Madhava Chamudita, and Mr. Akila Gunawardena, for their creativity and tireless work in giving Rescon its vibrant presence. We deeply appreciate the support of our sponsors and collaborators, and the academic staff and non-academic staff, demonstrators and research assistants of PGIS. And also, we thank all the support given by the former director, PGIS, Professor Pitavala, Registrar, University of Peradeniya, Deputy Bursar, Personal Relation Officer, Assistant Registrar of the PGIS, and also Professor Malkanthi Daundusekara and Dr. Lakshita Pahalagadara for being here with short notice. A special word of thanks to Dr. Kumudu Vijayasuriya and Mr. Saumya Bandara for their behind-the-scene contributions, and to the Sri Lankan media teams, especially ITN, for their excellent coverage through the Pini Vienna program. Most importantly, we thank all our participants, postgraduate students, academics, and professionals from Sri Lanka and abroad. Your energy, research, and participation give true meaning to Rescon. This year's Congress featured 236 presentations across 6 scientific themes, as mentioned by our editor-in-chief, Professor Namal Priyantha. These reflect the strength and diversity of research, scientific research in Sri Lanka and beyond. In preparation for the main event, we also organized 5 free conference workshops. So you can see some of the slides here, led by eminent international experts from Australia, the UK, and the USA, covering timely and important topics such as intermittent fasting and brain health, graduate studies, clean energy trends, academic challenges, and innovations in crop breeding. We sincerely thank all the scientists who contributed to these successful 5 pre-events, setting the tone for Rescon 2025. Finally, my heartfelt thanks go to everyone present here today for being part of this special occasion and for supporting the scientific vision of the Postgraduate Institute of Science. Before we conclude, I warmly invite you to join the interactive session by Professor Claudio Verani this afternoon, the session by Professor Jayantha Gunaratna tomorrow morning, and Dr. Dushanti Disanayaka's session tomorrow afternoon. We also look forward to seeing you at the Rescon dinner and the variety show tonight, a celebration of research, friendship, and collaboration that truly reflects the spirit of Rescon 2025. Ladies and gentlemen, thank you all once again, and I wish you an intellectually stimulating and rewarding Rescon 2025.